So in this video, this is another video about the circle, but the last time you saw the circle was centered at 0 and the radius was something r, so that's why we try to find out the equation of circle. Now in this condition we are assuming that our circle is centered at, suppose, G comma F, and then, or better if you say, I can choose write anything because this point is just centered and center of a circle can be placed anywhere, so it can be 0 0, this here, that, on the whole rectangular Cartesian plane. Now I just make it as minus G and minus F, so that some textbooks describe the situation in this way, and that's why I'm writing minus G comma minus F. And here this is my moving point P. So the P will be moving in such a way that its distance from this point, yes, so I can say this is my R. So RP is R. So it means the radius of the circle is R and the center is minus G minus F. And I assume that since this is my moving point, so I have to find the locus of this path. So I let the coordinate of this be h comma k. So by definition, so you see we get the situation. RP is equal to R. And what is RP? RP is the distance between the 2 points. So that can be written as square root of x2 minus x1 whole square. So I take this one as x2 and this is x1, so h minus g, this will become h plus g whole square plus k plus f whole square. Why plus? Because h minus g will become h plus g, and this one is your radius, that is r. So just square it and then replace h by x and k by y, you will get your equation. So first I will get h plus g whole square plus k plus f whole square is r square, and then I will get h square plus 2hz plus z square plus k square plus 2kf plus f square is equal to r square. So this is how you get our equation now, but I have to replace h by x, and that's why I'll give you the proper equation. So this becomes x square plus, I want to write this k square first, and this will become y square plus this part 2hg, I will become 2xg, and this 2kf will become 2fy, and then we have terms like z square plus f square minus r square is 0, and this equation is the equation of the circle, like this. Now this equation is called a two-dimensional polynomial of two variables. So the standard polynomial of two variables is general like the standard polynomial of two variable and 2 degrees, definitely not the homogeneous one, is x square plus y square plus 2gx plus 2fy plus c equal to 0. This is the standard polynomial. Like if you multiply the two linear components and then you get the polynomial of degree 2 and two variables x square, y square, 2gx plus 2fy plus c. So now this looks like this. It means this one can be made to represent circle, and if it is made to represent circle, what will be the center of the circle and what will be the radius? So I should have started this part first, but I just carried on this way, and then here you can return back and then start comparing the whole thing. So what I'll do that, I'll try to write this one as x square plus 2gx plus y square plus 2fy equals minus c. Now you see we have x square plus 2gx just like a square plus 2ab, so I need b square to make it a perfect square, so I'll add g square here and I'll add g square here also, because adding g square on the both sides of the equation will not make any change in the value of the equation. They'll all remain same. Same thing if here y square plus 2fy plus f square, and then here also I add f square. So now this part will become x plus g whole square plus y plus f whole square is, I want to write this as f square plus g square minus c whole under root whole square, only so that this can look very much like this. Yes, so here you see that we have x plus g whole square plus y plus f whole square and this now, but you know the distance formula between, like suppose if I just change this minus and plus like that, so what will have, my equation will become something like x minus g whole square plus y minus f whole square equal to r square. So this equation also I would like to write in this form. So what you see that I'll have x minus g whole square plus y minus f whole square and this will be under root g square plus f square minus c. This is g square plus f square minus c. It means that this equation represents a circle with the center. So this center right now is not required, so I can make it as minus g minus f, and the radius, this radius r, is nothing but under root g square plus f square minus c. Now you know that this square root, this is the square root, so it means the situations, we can have different kind of situation, like we have the radius r is under root g square plus f square minus c. Suppose if g square plus f square is c, then the c minus c radius will become 0. So this is the case when g square plus f square becomes c, this you can call it as case 1, and this will become a point circle. A point circle is just a circle where the p, now if the p comes and meets the r, the whole circle squeeze will become a point, so it will just have a coordinate and radius will become 0. Now if g square, case 2, if g square plus f square is greater than c, then in this square root you will get something positive, so you get real valued answer for that, because square root of the positive number is a real valued value plus minus something like that, it should always be positive, so that is called the real circle. But case 3, now if you know about the imaginary number, it's also called as the complex number, then if g square plus f square minus or is less than c, then in the square root you will get a negative number, and the negative number of a square root always gives a iota, that is I is under root minus 1, and that's the beginning of the complex number, so this one is called imaginary circle. Imaginary circle. This is the basic idea about the circle. In the next video we'll try to solve another example, and then you will be able to test. So now to whatever we have discussed, now let's take one example and try to understand that can that equation, like suppose I have an equation like 3x square plus 5y square plus 7x plus 8y plus 9 equal to 0. Does it represent a circle? The answer is no. Why? Because you see this one, if you try to get rid of this 3, so you can divide both sides of the equation by 3, so this 3 will be gone from here, and then you'll get 3 everywhere. Here there is no problem, but this one is not a, because you can never convert it properly into the perfect square of the y plus something whole square, because it will always be something y whole square. So the requisite condition that the coefficients of both x square and y square should be same. Like if it is 3x square, this should also be 3y square. If it is 5x square, this should also be 5y square. So now I remove these things. This is my general equation plus 7x, and I want to try to understand that if this is the equation, then where is it a real circle, or is it possible to have the circle with this form, or if it is a circle, then what will be its radius and the center. So the better way, what we have discussed here, that you just try to compare this with the standard form, that is x square plus y square plus 2gx plus 2fy plus c equals 0, and then if you do it, then this represents a circle with the center minus g minus f and the radius, that is g square plus f square minus c. Now the case, now suppose if you compare, so here see, we get 2g is 7, 2f is 8 and c is 9. So z is 7 over 2, f is 4 and c is 9. So the center possibly looks minus 7 by 2 minus 4. But what about the radius? So the radius is r is under root g square, that is 49 over 4 plus 16 minus 9. Then how can you get this one? So right here 4, 49 plus 64 minus 36, that is under root, this is 4 here, and the 36, and then this is 66. So if I take it as 66 and this is 36, and 66 minus 36 is 30, and then 2 less, that's 28. 28 plus 40, 40, 20, 60, 9 is 17, 74. So it means you are getting under 74 by 4, which is greater than 0. So this is a real circle of radius under root 74 by 2. Now if you do not know how to find the square root of 74 without using calculator, then you can use the hard rule, which goes like this: 74.00, 0.00, 0.00, start pairing, and then right here 8864, and then here you are getting 10, decimal is coming here, so put it there. And if then your whole pair comes down. If you do not understand this method, you can write in the comment section. I'll explain one more thing, because people are forgetting so many important things these days under the influence of the gadgets. So this is 1 6, so 8 plus 8 is added 16. Now I have to put one digit here and the same digit there also. So suppose if I put 16, 6, 9 is 6, go like 16, 6, 9 is 6, 6, take it out, 6, 6, 36, 6, 3, 6, 6, 9 is 6, and 3, 99. So this is 9 and 9 and 6, 4, 9, 6, 15, start going 6 times. So I have to change this one, I make it 5. So 5, 5, 25, 5, 2, 5, 6, 32, 2 and 3, and 5 on 5, 3, 8. So 8, 25. So 10 minus 5 is 5, 9 minus 2 is 7, and then the 9 minus 8 is 1. And this is already gone. So again I have to continue at 5, the latest digit. So it will become 170, 2 more zeros will come here. And then it's 1700. So I think it will take it 9 times. Let's check it out. 9981 18908 9763 6919 615 is going. So I don't care what it is, but I am getting the idea that it is 8.59, and if I round it off to one significant, not one significant, two significant figures, then this will become 8.6. So this is my answer, 8.6 units, and this circle is the real circle. I hope that you enjoyed. Thank you very much, and watch to our next video to understand more about circles.